Hello there. I just learned some new things by reading articles and asking ChatGPT. So I just want to quickly share it with you in this video. We uh, discussed about electric fields and magnetic fields and gravitational fields, and I want to give examples of electric fields in this video. Electric fields are usually found in electronic circuits, in devices that work with electronics, like microwave oven, television, monitors, cell phones, and all those things that has electronics in it. Electric fields always come into play. But those are like small electric fields. Those electric fields are like very minute electric fields. But then I asked ChatGPT about something that's a bigger electric field, and then ChatGPT told me about colliders and particle accelerators. So there is this thing called Large Hadron Collider, and some other colliders and particle accelerators out there somewhere in Europe. So they use very strong electric fields in their experiments. So I just learned that. And another example of very strong electric fields is electric lines, overhead electric lines, which is used for transmission of electric current, electrical energy to our homes from the generators. So there also they say the electric fields involved are really high, very high. So those were two examples of very high electric fields. The other electric fields out there are like in small devices, as I said. Okay, I said about that. The next thing is about magnetic field. In my last video, I said magnetic fields interact with only charges. So I want to make a clarification here. Gravitational fields interact with matter. Electric fields interact with charges. And magnetic fields interact with both charges and matter. That seems to be the right thing. That's because you might have noticed magnets attach that come closer. So magnets that attract iron materials. So there it's matter. Iron nails, iron is matter, definitely matter. So magnetism interacts with matter as well as electric charges. So that's a new thing. That's a correction which I need to make. Now about electric fields and magnetic fields, one important factor or parameter which I forgot to say is that unlike gravitational fields are always attractive. In gravitational fields there is only attraction, but in electric fields and magnetic fields there's not only just attraction, there is repulsion also. So there are poles. There are two poles for in electric field and magnetic field. In gravitational field, there is only one thing, that is mass. There is no positive mass or negative mass. As far as I know, there is no negative mass. There is only positive mass. Mass is always positive. There is no negative mass. So, but not the case with electric field. In electric field and magnetic field, in electric field there is positive charge and negative charge. So the law is like that: positive charge and positive charge will never come together, they'll repel. Negative charge, so like charges repel, unlike charges attract. So that's basically in electric fields. In the case of magnetism, there are some things called magnetic monopoles which do not exist in reality. In real world, only magnetic dipoles exist. A dipole is like a piece in which one end is positive, or we call it as north, and the other end is negative, or we call it as south pole. So in this world, magnetic monopoles don't exist. Like you never get a piece where it only has a north pole or the positive pole of a magnet. You always have dipoles in magnetism. It's really an intriguing topic. Magnetism is really an intriguing topic because magnetism, as you said, it interacts with matter and charges. So it's kind of a combination of gravitation and electronics. So magnetism is again a place where I need to do a lot more study on. But anyway, one more thing. My point is, in electric field and magnetic field there is attraction and repulsion, but in gravitational field there is only attraction. So that's my next point. And then magnetic fields interact with charges as well as matter. Yes. And then one last thing, in my last video I told that electric field, gravitational field, magnetic field, they are all non-contact forces. So my friend on seeing that video, he kind of commented in Malayalam. The comment was like, കാറ്റടിച്ചാൽ കറണ്ട് പോകും, പക്ഷേ കറണ്ട് അടിച്ചാൽ കാറ്റ് പോകും, which actually translates as, if there is wind there will be power cuts in the houses, but if you touch electricity, if electricity comes in contact with you, you will die. But it works in Malayalam when said in Malayalam. So that was a joke which I just thought of sharing. കാറ്റടിച്ചാൽ കറണ്ട് പോവും, കറണ്ട് അടിച്ചാൽ കാറ്റ് പോവും. So that was also very interesting. So today also I'm indoors. I did not get the chance to go outdoor and record. So that's it. I wanted to keep the video very short, but it's already so long, 6 minutes. Very sorry. Okay then, bye. Thank you. See you.